Okay, here we go. Quick little review of what we've talked about, because today's lesson is kind of like, it's got some similarities, I'll say it that way, to what we just finished doing with this triangle. Watch. If I had this is what you don't even have to write this part down. This is what we've been doing. If I said that, remember how we did this? I'd say that's the smaller one, and let's say that's the bigger one, and that's the medium one. Okay? We'll make it look a little more medium. Okay, you follow me? So just looking at the marks right here, that's the smaller. Now, I don't know if it's to scale. I don't really care. But this would be the smaller side. This would be the one that's in the middle, and this would be the largest side. Okay, we'll just say it like that. They never do that in the book. I just think it's nice to look at it and say, oh, the little one's the small one, the big one's the big side. Is that okay with you? If that's true, I'll label this ABC. If this is true, if that's the smallest side and that's the largest one and that's the middle one, you can tell something about the angles, right? So what's the smallest angle on this? Angle C. I'll make a little tiny arc there. What's the medium angle? Okay, it'd be A, so I'll make more of a medium arc. Okay, and what's the largest one? B. And how do we know that? Because the largest angle is opposite the what?
Biggest side.
The largest side. Okay, and the smallest angle is opposite the smallest side. Okay, now watch what we've done. That's review. Okay, we just did that, what, a day or two ago, right? So we've learned that, but what we're going to do today is we're going to compare two triangles to each other. Not just the angles of one triangle, according to the sides of that one triangle. We're actually going to take two triangles and we're going to compare them to each other. And we've kind of done that before. Let's take that same triangle and make it a little bit bigger. We've kind of done that before. Watch, if I copied and pasted, what kind of triangles do I have now?
Isosceles triangles.
I copied and pasted. Thank you, Chris. It's congruent. They're congruent triangles. All right? Chris said it first, though. At least he's the first one that I heard. Okay, so look. These two triangles are congruent to each other. So that means that, what? This side, the corresponding sides are equal, right? So that side's equal to this side. This one's got 2 tick marks, that one's got 2, and this one's got 3, and that one's got 3. All right, so if this triangle has 3 sides equal to the 3 sides of the second triangle, you see the difference what we're doing today? We're comparing one triangle to another triangle, not just the angles inside one triangle. We're comparing 2 triangles to each other. So if I said that these 3 sides are equal to these 3 sides over here, these triangles would be congruent. Agreed? All right. That means the sides or the angles opposite those sides would be the same as the angles opposite the same sides over here, right? We've talked about that. We've had a whole chapter on congruent triangles. But watch what I'm going to do. I'm going to do something a little bit different here. And I'm going to try to use my little program to help me out. What I'm going to do is I'm not going to change the length of this side right here. Okay? I'm going to hit the rotate tool, and it would be really nice if I could get that to stick right there. I wish I could figure out how I could get that to just stay right there and take this and just swing it around. But I can't, because when I take this and swing it around, it swings through the middle. You know what? Let me see something. I wonder if I can... Nah. I was thinking maybe, because it's got like a little... Sometimes when you click it, there's like a little circle in the middle. I thought, well, maybe I could put it here. Maybe that's where it hinges on. But that's okay. I'll save that for another time. So watch what I'm going to do, though. I'm not changing the length of it. You understand? All I'm doing is just changing the angle. We'll make it fairly severe. And then I'm going to put this back where it was. About right there.
And it looks like a little cat with a mustache.
Okay. And then watch this.
Okay.
So look, I still have these 3 sides equal to these 3 sides. Would you agree? But now I definitely don't have congruent triangles, do I? Alright, so what am I going to have to do to make this a triangle? Well, I could take this side. Now, what's going to happen to this side, though? And what did let me ask you this. What did I just do? If this angle was this amount, and before, right, it was going over here, what did I do to this angle? I made it bigger, didn't I? I increased the measure of that angle. Now look, I didn't change this length right here. I didn't change this length right here. I just changed the angle, didn't I? But what's going to happen to this third side once I change that angle? If I make this into a triangle and swing it all the way down here like this, look at the length between, look at the length what it is now compared to what it was before. What is it?
Longer.
It's longer, isn't it? Yeah. Okay, look. This is longer than this was, than it was originally. You with me on that? So what did I change? I kept these two sides the same, didn't I? I changed the angle. If I change the angle, guess what it's going to do to that opposite side? It's going to make it longer. So guess what? If I'm comparing two triangles to each other, if I have two sides that are equal, follow me? This all has to be true. If these two sides are equal to these two sides right here, and the included angle is unequal, if this one is larger than this one, then guess what? The side opposite the larger angle, I'll make big tick marks right here, okay? The side opposite the larger angle is going to be what? Larger than, talk to me. The side, right, opposite the other angle. Does that make sense? See, this angle right here became bigger, didn't it? And I'm going to show it a little bit bigger, watch. This was a bigger angle right here. So if I've got a side and a side equals side, right? Or this side equals this side equals this side. The angle in between, the included angle, now is bigger than this one. So guess what? The opposite side is going to be bigger than this opposite side. Do you agree with that? I think that works pretty well. I think you saw, visually, I think you saw what was going on here. So this is what I call it. Now, I didn't make this name up. I taught out of another book that used this, and I like the name that they use better than what this book is using. They call it the Hinge Theorem. The reason they call it the Hinge Theorem is because it was out like this, and what did we do? We took it and we just kind of, it's like this, right? If this is hinged, if it's locked on right there, what did I just do to this side? It went like that, right? It's like a door opening. Follow me? So they call it the Hinge Theorem. I don't like that name because it doesn't really tell you what's going on that much. What I say is this. Remember, it was, when they were congruent to each other, when I first put these triangles up here, it was side, 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 wasn't it? But now, what did I do? I got two sides that are still equal to each other, but what did I do to this angle? I changed it. So I call this the side angle side inequality theorem. I don't call it that. Other books call it that, okay? This book just doesn't call it that. They call it the Hinge Theorem, and I'll put that in parentheses. They call it the Hinge Theorem. But I like side angle side inequality better because I have two sides that are equal to two sides, and I have an unequal angle. See, this angle right here is unequal, okay? It's an included angle, but one angle is bigger than the other. So if one angle is bigger than the other, guess what's true about the opposite side? The opposite side, opposite the big angle, is bigger than the side opposite the small angle. Make sense? Isn't it very similar to what we did with that one triangle? Except before we just had one triangle and we're comparing the angles compared to the sides of that one triangle. This one we're talking two separate triangles. I've got this side equal to this one, this side equal to this. I change the angle. This side is big, so it's got a big opposite side. This side is smaller, it's got a smaller opposite side. You okay with that? Okay. And I call it the side angle side inequality. Now what if we did this? What if I said, I didn't change really the angle because we were given that the two sides were equal, right? These two sides are equal to these two sides, and I changed the angle. I made this angle bigger than this angle. So what was true? If this angle is bigger than this one, then the opposite side is bigger than this opposite side. What's the converse of that, do you think? If what?
The side is bigger than
That's right. If I'm given, exactly right. If I'm given that this side is bigger than this side right here, then that's right. Then, and you've seen this a dozen times at least, haven't you, this year with geometry. We do that a lot. We take a theorem and then we do the inverse of it. We take the if-then, we switch it around, and that's exactly what we're doing. So if these two sides are equal to these two sides and the third side is unequal, right? If this side is not equal to this one, which means one's bigger than the other, then guess what? The opposite angle must be bigger than this opposite angle. It's kind of the same thing, isn't it? Kind of. Subtle difference, but it's kind of the same thing. And that's it. By the way, we call that one, now what were we given? We were given two equal sides and then one unequal side. So guess what I call this? The side. What do you, inequality, right. Now you have to say inequality because this is not congruency, is it? These triangles are not congruent to each other because this side is bigger than this side. All right, so we don't call it congruency. We call it side inequality. They call it, actually I should have put this at first. They call this the converse of the Hinge theorem. Okay, the converse of the Hinge theorem. I kind of like this better, though. I like side angle side inequality, and I like side inequality. It just depends what book you go to and what the author decided to write in there. Okay, does that make any sense at all? Let's do an example, okay, and then we'll be done.
We figured it out.
All right.
Guys.
Well, Maddie Fresh figured it out. Okay. So.
I'm on the wall right now, guys. You can
well, it was my mistake that helped too. Don't forget. Because remember. All right, I got to put it on the rotate thing. So, here's the circle thing right there, and I stick it right there, and that's where it's going to hinge around. And oops, no, I still got to use the rotate. And now I take it, and oh yes, that's going to help so much. See, it keeps the length of it the same, doesn't it? It doesn't change the length of it, but it does rotate around that. Now I got to figure out. It's about right in there. Okay, good. Wow. You just don't know how happy I am.
Hey, it looks like a corner.
About that. All right, so that goes like this, and this goes like this. All right, let's put some numbers in. That's 65 degrees. Make sure you're watching my time so I don't go over. That's 11. This right here is 6x plus 15 degrees. That's this angle right here, okay, right next to, adjacent to the 65. They tell you that this side is equal to this side, and it's EJHG in that order. Okay, here we go. It says, find the range of possible values for x. So what I'm going to do is this. Let's take a look at our situation. I've got this side equaling this side. Do I have another side that's equal to another side of this triangle? Bang, right there. Do you see it? I've got two sides that are equal, and look at the third side. I've got an unequal side. Guess what? That's my side inequality theorem. So that says if I have two sides that are equal and one side that's not equal, then the angle opposite the largest side is going to be bigger than what? The angle opposite the smaller side. So looking at this information, what can I say? I can say that 6x plus 15 is what? Greater than 65. Very good. And now I can solve for x. So 6x is greater than what? 50. And then divide by 6. So what's that? 25 over 3. Okay, 8 1/3. All right, so x is greater than 8 1/3. Now I'm running out of time. Now it's greater than 8 1/3, but what is it less than? That's right. So this thing right here, 6x plus 15, has to be less than 180 degrees. How do you know that? Well, because look, it's part of a triangle, isn't it? So this angle and this one right here have to add up to 180. So this has to be less than 180, right? If it's part of something that adds up to 180. So we say it's less than 180, so 6x is less than, what's that, 165, and then divide both sides by 6. I have no idea what that is off the top of my head. Let me look in the book. What is it? 27.5? Okay, oh yeah, x is less than 27.5. So, look what we have. X must be bigger than 8 1/3, and it's got to be less than 27.5. How do I write that? Just like this. Put 8 1/3 right here. Put 27.5 right here. You could put a half or 0.5. It doesn't make any difference. And that is your range of possible values for x. It's not just equal to one number now, is it? Because I've got inequalities going on here. So it's not just equal to one particular number. It could be any number between 8 1/3 and 27.5. Can't be less than this. Can't be greater than that. It can't even be equal to those two numbers, can it? X could be any number that's in between here, and that'll make this angle bigger than this one right here. We good? All right, let me give you a homework assignment, and we'll be done. Let's finish recording here. Here we go. There's your assignment. Pages 372, 373, 10 to 15, 17 to 20, section 5, 6. All right, say bye. Have a good weekend.
You have to go 10 more seconds being fun.
Okay, go all the way to the edge.
Yeah.
No, I don't want to end exactly to 15.